All right, just to reiterate what we had on the previous video, if we have h at x being the composition of g at f at x, then h prime at x will equal the derivative of g at f of x, derivative of g at f at x times the derivative of f at x. So the f at x is what I'm going to call the inner function, the g at x is the outer function. So if I'm looking at example 1 here, my inner function, my f at x, is the 5x squared. So I'm just going to write this down here, 5x squared minus 2x plus 3. And my g at x, my outer function, is whatever I have to the exponent of 3, so x to the exponent of 3. So if I look at the derivative of this, so I don't have to be nice and write that out thrice and then try and expand and simplify it, because boy oh boy, that takes a lot of time and effort and all that kind of stuff, and you can really appreciate that now that you've done some questions like that. If I look at my derivative of the outer function, that 3 is going to pop down in front. I'll have 3 times the base, and then I'm going to reduce that exponent by by 1 power, so the 3 becomes a 2, and then I need to multiply that by the derivative of what's inside. So 5x squared's derivative is 10x, minus 2's derivative, or minus 2x's derivative is minus 2. Now the nice thing about this is it's almost all in its factored form. If I want to solve for critical numbers, which is of course coming down the road, I'll notice that this also has a common factor of 2. So if you look up your answer with Bob, you might see that they'll pull out a 2 out of that and take that 2. So let me pull that out. That's going to be a 5x minus 1 now. But this would still be the same here. I would take that 2 and multiply it by the 3. I'd also want to check and see if this trinomial inside of here will factor, because if it does factor, that will help us also find critical numbers. But of course we've got the quadratic formula that we could use on that if need be. Okay, as I was saying, for the critical numbers, I got interrupted and I had to put the video on pause. For the critical numbers, I would be looking for where my factors are equal to 0. I did quickly check to see if that trinomial, the 5x squared minus 2x plus 3, would factor, and I don't think it does. But I could go into quadratic formula for that potentially. The next one, differentiate. We've got h at x is equaling the square root of 8x squared plus 4. Now, before I actually take the derivative of that, I'm going to rewrite it, that square root, as an exponent of 1/2 on this, because then I can follow that pattern that we were using in the previous example. So I'm going to find the derivative, h prime at x would be equal to, I'm going to pull that exponent down front, 1/2. We're going to have what's inside, the base, and then I'm going to reduce that exponent by 1 times the derivative of what's inside. So 8x squared will become 16x, 4 would be 0, we would end up with that. I'm going to simplify that just a tad here. I'm going to take 1/2 of the 16x and get 8x. And we could write that back in its radical form. The exponent of -1/2 would send that also back down to the bottom, not back down to, but to the bottom, because it wasn't on the bottom before. And it would be now a positive 1/2, which is the same thing as this. Okay, so hopefully that makes sense. You might have to play with the answers a little bit to make them match the back of the book, but hopefully that gives you a sense of what you're doing with that. Before I do f, I also would express that as a power. So I'm going to slide that 6x cubed minus 5x plus 1 up to the top and make that exponent a -2. So that's still f at x. And now I'm going to take the derivative. So I'm going to pull that exponent of -2 down front. We're going to keep the base as it is. And then we're going to reduce that exponent by 1. And then we have to multiply that by the derivative of what's inside. So 6x cubed, its derivative, 6 times 3 is 18, x squared minus 5x, its derivative would be minus 5. Okay, which again, you could rewrite that as minus 2 times 18x squared minus 5. And then that would all be over that to the exponent of 3. Okay, I could have used the quotient rule with that one, but I still have to worry about taking the derivative of what's inside. So it's not so easy to do the way it is, but this hopefully works out and makes sense for you. All right, go ahead and try your assigned questions, and let me know, of course, if you have any problems.